All right, good morning, everybody. Hi, thank you for joining us today. My name is Jim DePalma here at Wales-Darby. I'm a part of the contractor services team. We are the tech guys, the trainer guys, the design guys. And today we're going to present a webinar on venting on Centrotherm product. With me today in the background, because it takes a team to do these webinars, is Christiane Levine. She's in the hot seat, as we call it. She's running the computer, and Eric is running the cameras, Eric Hayes, and we're all excited to do this. We're having a good time already. So what we're covering today is Centrotherm product, and our goal today is to make everybody understand what is available to you in the world of venting and why you really want to be very aware of the products that you choose. Because based on the system that you put in, is it a high temp system? Is it a low temp system? Is it a condensing system? You want to make sure that your venting is not an afterthought. You want to make sure your venting is a complete safety system. Now, we go out on jobs a lot and we'll help contractors figure out the load that they need, and maybe even help design the near boiler piping, or for anything on a tankless, the piping next to the tankless. And one of the first things we look at is how are we going to vent that appliance? It's extremely important, and it's something that should not be an afterthought. So every time I do a webinar or a class, I always want to make sure everybody leaves with one specific item in the back of their mind that they're always thinking about. And I want you to remember or think about this, that venting is a safety system. Don't think of it as an afterthought. It's not something that you're going to force your way in after I've got my appliance all hooked up. It's something you really have to plan out beforehand, because it is that important. Okay, we're really talking life safety systems here when it comes to venting. So we're going to be talking about Centrotherm. All right, it's a product that we represent. We're here doing this webinar today, sponsored by Aaron & Company, and it's a product that they inventory. So we want you guys to be familiar with it, comfortable with it. Please type in any questions you may have. Now, if this is your first time ever seeing a webinar, on your screen, you can go up to where it says display setting. I'm sorry, where it says webcams. And if you click on that arrow, the down arrow, and click on left, you'll put me on the left-hand side of your screen, and you'll have the presentation on the right-hand side. And then in between the two, you'll see three small little hash marks. And with your cursor, you can click on that and expand and contract the screen, so you can view this any way you choose. You can either have a lot of me, or you can have a lot of the presentation, whatever you choose. And then the upper left-hand corner of your screen, you'll see a chat box, and you'll see questions, and that's where you can type in your questions. All right, so if there are questions that come up, my team will let me know, and we'll address them as we go forward. All right, so going forward, let me give you some history on Centrotherm. All right. They're a very large company. They're across the world here. You can see them in the US, up in the Albany, New York area, but we're also in the UK, France, Italy, Belgium, the Netherlands, Germany, and China. So this is not a new outfit. They've been around for quite a long time, and they concentrate on venting material for all appliances. In our world, we're going to be concentrating on category 4 condensing type product. So let's start off with some history. How did we even get to this point where we have all these different materials for venting? So what we commonly use, and you can see on the screen, we commonly use either PVC or CPVC, polypropylene nowadays, or stainless steel when we're concentrating on condensing type of product. So each one has advantages, and they have some disadvantages, and things that you should be aware of. Okay, so what is the history? How did we even get to this point? Well, when I first got into the industry in 1990, basically everything was metal vent, because it was high temperature product. It was cast iron product, high temp. Any classes that we do in the world of hydronics, and we're talking to you guys, we'll refer to product as high temp or low temp product. So when we say high temp, we're thinking cast iron. you're going to be making 180, 190, 200 degree water. So your flue gas temperatures will be 20 degrees higher. Hot flue gas, you can't see it. It's all done with metal venting, and that's what we did for a long, long time. So that product of combustion is our flue gas, and we have to obviously get it out of the building. Otherwise, we can kill people, we can hurt people with it. And what makes up flue gas, as it says on the screen, is hydrocarbons, pollutants. All right, we have to get it out of the building because it's highly toxic and we can cause harm to the people in the building. So now, as efficiency progressed, as the products or the appliances, and the appliances you see behind me, tankless water heater, condensing boilers, as the efficiency grew, got better, our venting had to change. So we're talking, let's see, early 90s, mid 90s, where hydrotherm pulse combustion came out, and that had to change the venting. Then we got to late 90s, and you had the Munchkin boiler come out, and that had to change venting, condensing product. Early 2000s, Weil McLean Ultra product comes out, and the venting had to change. Because of condensing, we had to have a vent that could handle the condensate. Condensate's very acidic, and if it was metal venting, it would destroy the venting. So we had to come up with different ideas, different materials on how to vent. And then that spawned other categories of venting. So the categories that would come from this then became category 1, 2, 3, and 4. Again, our focus today is going to be on category 4, but let's make sure everybody understands these categories, because you'll hear people throw these names or different category numbers out there, and I want to make sure everybody understands what they are. So category 4 is your typical natural draft. I'm using a masonry chimney. I have high temp flue gas, high temp water going out to my system, your traditional cast iron boiler system, okay? Category 2 is a negative pressure and condensing type of system. The appliance can handle the condensate, so our venting has to be able to handle the condensate. And the flue gas temperatures will be less than 140 degrees. Category 3 is an airtight. This is positive pressure, non-condensing. So again, we're above 140 degrees again. And then category 4, which is where we're concentrating today, this is airtight, positive pressure, condensing. Everything is below 140 degrees. And that's where we're playing when we do tankless water heaters, or if we do any type of condensing boiler. All right. So now this is interesting, and this is a phenomenon that we see a lot of times when we go out on a job, and whether we're going to be looking at the piping with the contractor, helping them out with pumping, all right, and whosever appliance it is, what we normally see sometimes is condensing product installed and never running in the condensing mode. So let's make sure everybody understands what condensing is. What it actually is the flue gas temperatures are going to be cooled because the return water temperature is 130 degrees and less. As you can see on there, it's the dew point of natural gas. So really at that 130 degree return water temperature is where we take the products of combustion, which are a gas. You can't see it. They're that hot. And we cool them down from a gas back to a vapor. And it keeps getting cooler, so now it goes from a vapor back to a liquid. And inside that liquid is latent heat energy. So our appliances now generally will have either a secondary heat exchanger, which can accept that condensate, that latent heat energy, not corrode, but reabsorb that latent heat energy back into the appliance. And that's what makes that appliance 90 or 95% or better efficiency. All right, your standard cast iron is 80%, 82%. So another way to think about it is for every dollar I spend, 18 cents is going out my chimney and 82 cents is heating my house. If it was condensing, every dollar I spend, 90 cents or 95 cents is heating my house and only 5 cents is going out the chimney. All right, so that's what condensing means. And The appliance will run that way if it's always going to have that cold return temperature, water temperature coming back to it. So what we end up seeing out in the field is a lot of these appliances, boilers, tankless water heaters installed, but always running at high temperature. So contractors sometimes get confused. Well, it says it's condensing. It says it on the box, but if I don't set up the system to run that way, my flue gas temperatures are now higher. And in all of your install manuals, and I don't care whose manufacturer it is of that appliance, all the install manuals will tell you that based on your system temperatures, they'll give you your option of different venting material, but you have to be running in the condensing mode. Once you're outside of that, if they're telling you PVC is acceptable, but you're running higher than those temperatures that they're looking for, now you run the danger of damaging the venting material that you're using. And we don't want that to happen. So at this point, I'm just going to stop for a second and ask the question, does anybody have any questions of what condensing actually means and how it happens? Any questions coming in there, ladies, on the screen? All right, so I'm going to move forward. So what can happen if I'm using the wrong vent material? So here's where, if the system was operating low temperature, because you can make cast iron product condense, you just have to bring 130 degrees back to it, and you'll make that product condense. We'll end up damaging the boiler, and as you can see on the screen, you will eat up that metal venting. Now, something like this can even happen even if you're running your system at high temperature. I actually had this happen in my own home because the boiler got dirtier and dirtier as the years went on, and it was also oversized. And because it was oversized, it would short cycle. And that short cycling would happen quickly. And as the boiler got dirtier and dirtier, it was a copper fin type of boiler. So they made high temperature very quickly because of low water content. Flue gas would just kind of be hanging in there in the venting. And eventually, this is what I had happen also in my own home. So if we have any type of condensing happening with this type of product, you can see how it's going to eat through the metal because it's very acidic. All right, we have to make sure we have the right products. So that's brought us to then, well, what do we use? And it came up to then what was the available venting at the time and what was the most cost effective. All right, so as we go on, that brought us to then using PVC, because as the appliances got more efficient, their costs went up. And then, what were the options? PVC or stainless steel, with stainless steel being quite pricey. I remember being in the industry early on when this was happening, and if you didn't sell a condensing appliance, your rebut to the efficiency was, yeah, you're going to spend a lot of money on the venting though. Almost as much as the appliance. So PVC was approved by those manufacturers as long as you operated in the condensing mode because it was available and it was cost effective. All right. We don't want to say cheap, cost effective. Okay. So, and what they concentrated on was not so much temperature, but the ability of the material to handle the acidity of the condensate itself. All right, so that's why PVC was the natural option, as it says there on the screen. And the appliance manufacturers, OEMs, as we say, would concentrate on these different standards, and it was really based again on the acidity of the condensate, not so much flue gas temperatures. Okay, so you can see the different standards on there. If I could see it, ASTM D, thank you, Chris, 2564 and D 1785, that type of stuff. That's really where they concentrated. And then you got the different associations, the NFPA 54, which is National Fire Protection Association. They allowed it. International Fuel Gas Code allowed it. International Mechanical Code allowed it. Your local inspectors allowed it because these are the codes that they follow. So again, what did they concentrate on? Well, NFPA 54, what does it say there right there on the screen? The appliance manufacturer's installation instructions shall identify the specific pipe material, plastic pipe material, all right? The plastic pipe venting material shall be labeled in accordance with the product standards specified by the appliance manufacturer. International Fuel Gas Code is going to echo the same thing. Category 4 appliances, not required to be listed. The venting doesn't have to be listed where it's, unless, I'm sorry, I'm falling over my words. Is not required to be listed and labeled where such vents are specified by the appliance manufacturer. Okay, International Mechanical Code, again echoing the same thing. So basically the appliance manufacturer said, as long as you're running in condensing mode, as long as you're running at these lower water temperatures, we approve you using plastic venting. PVC, CPVC was approved. But also let you use stainless steel, but everybody obviously would go to the plastic because it was less money. Again, as long as we're running in condensing mode, that's was approved and that would work, okay? Very important that I'm going to drive that home a lot, okay? Because again, I see a lot of condensing appliances installed running at high temperature, you know, meaning they're running at 180 all day long. And if they're making domestic hot water, they're high firing a majority of the time, and you'll see PVC venting starting to discolor. You walk onto jobs to service some of those appliances, take a look at the venting. If you see it discoloring, you know the system is running at high temperature and it's the wrong material. So this is our history. This is how we got there. So the common denominator between all of them was the appliance manufacturer dictated the venting. And code officials went with it because the appliance manufacturer said that was ideal. All right. Hopefully everybody understands that. Any questions, ladies, coming in on that? All right, we're good to go. So what did they really concentrate on? Again, these standards, I just want to let you know that D1785, F44.1, and it was really more of a standard for the water, the condensate, the acidity. Can the material handle that? But those codes, these ASTM codes, basically really concentrate on the liquid, and it'll state very clearly that the piping is for liquid use only, not really for venting. All right, so there's your D1785, and there it says liquid only. If it was F441, same thing for CPVC, liquids only, not temperature. Here, this is also from one of our PVC manufacturers. They even call out that it's for liquid only. All right, their standard is for liquid only, not venting. So we really have to be careful, because when we bring this up to the contractor out in the field and we say, hey, look, this is starting to affect the venting, well, they say, well, the manufacturer approved it. But if you look in the install of that manufacturer's appliance, it will state you have to be in condensing mode. So I'm really driving this home. We happen to represent this manufacturer of condensing boilers, and they dedicate 11 pages to venting. Let me say that again, 11 pages to venting. All right, and they clearly call out, based on your system design, where it's going to be operating, what venting material is approved. So stainless steel works across the board with anything, whether it's natural gas, propane, or oil. All right, high temp, low temp, no problem. But when we get to PVC, CPVC, we do have to be careful when the temperature of the system changes. So how does this happen, or how did it slip through the cracks, as it says here on the PowerPoint? Because manufacturer spec said it was okay to use. All right, so there's our history of how we got to this point. Things to think about when we are now using our venting is the possibility of failures. Now, when you look at this picture, you can see a discoloration on the piping. And I really want you guys to pay attention to this when you're out there in the field, because you're going to see this more and more, where either flue gas temperatures are too high or UV affects the piping that's outdoors. And believe it or not, UV rays affecting the pipe outdoors can affect the pipe indoors. The material that you use to install or put together your venting system has to be able to handle the temperatures and any UV type of radiation, okay? So generally when it comes to PVC, CPVC, you're asked to cut the pipe, you're asked to bevel the pipe, you have to glue it, there's wait time, all right? You have to be able to support the piping, it's not light, all right? We can't have any sagging, we have to have pitch, all right? So there's a lot of things to look into as you're making these systems, okay? Other considerations or other options for you is our poly pipe. And since we're talking Centrotherm, we're talking our Centrotherm pipe, which comes with built-in pitch, comes beveled, okay? And requires no glue, solvents, or anything to put together. So once you put the venting together in the world of Centrotherm, you're ready to go. If it was a PVC, CPVC type of system, now you have to wait for the system to cure. If you don't, and you light off your appliance, those fumes from the glues can explode. So we really have to be very careful of that. And we've seen that happen, okay? So your considerations with materials, again, is PVC, CPVC, polypropylene, Centrotherm venting, or stainless steel. And there's, you know, they all can do different things, but the temperature is really important. So stainless can handle the highest temperatures, all right? And it doesn't matter what type of fuel you're using, okay? Schedule 40 PVC or CPVC, you really don't want to be above 149-degree flue gas temperature. Flue gas temperatures are basically about 20 degrees hotter than your supply water temperature, right? So that means you're in the 130s going out there to your system. You got to make sure your system is designed that way to heat the building, all right? The polypropylene has got a rating up to 230 degrees. And you're going to see in a few slides going forward, we are actually rated up to 300 degrees. So if my system is making 150-degree water and I'm maintaining a 20-degree delta to get 130 to come back and cool down those flue gas temperatures, my Centrotherm poly venting can handle that fluctuation in temperature, where the CPVC or PVC cannot, all right? So what can happen if we fall out of temperature? Well, it can happen, a lot of things can happen. And what can cause us to fall out of temperature? Not maintaining the product. Years ago, there was articles on, you know, condensing boilers. What would happen if nobody maintained them? All right, what would happen if nobody maintained it? What would happen if nobody went and periodically checked the heat exchanger, cleaned between the coils to make sure that it was going to function at its peak efficiency? And after 3 years of no maintenance on one boiler, it went from high 90s into like mid 80s, you know, 83, 84, 85, which is still better than 82. But that means as the heat exchanger collects more debris, it requires a higher temperature to make the supply water temperature that we want. That means my flue gas temperatures get higher. That means it can affect my venting. And as you can see by the timeline here, less heat transfer because it'll block the heat exchanger, efficiency decreases, temperature increases, and we could have a failure on the venting, okay? Now, this next slide is really interesting, you know, and I don't want to, you know, scare people because it talks about deaths. There's 19 deaths a year and poisonings. That is important, and we do have to be very aware of that. But what really stands out here to me is the failure that you see on the screen for this appliance, this system, took under 10 years to happen. So that's proving that if we don't maintain our systems, how the efficiency falls, the temperature that it has to create rises, our flue gas temperatures get hotter, and based on the material we're using, it could cause a catastrophic effect. So we do want to be really, you know, cognizant of this, guys. This is really, really important. So because of things like this, the standards have changed, and now UL standard 1738, this is our gold standard. This is the standard when it comes to venting. And you will see locally within probably a year or two, because I've talked to local code officials and the state, that this is going to be code here in our area. I couldn't tell you exactly when. I know they move slow, but they're getting very, very close to having this happen. So UL 1738 is the gold standard when it comes to venting, when it comes to your products for category 4 appliances. That's what I'm concentrating on, but for category 2, 3, and 4 appliances. And it's a very strict standard, and it takes a lot to get this standard. So what's interesting about this standard is all these different tests that it has to pass. And we highlighted a couple of them that are really pretty interesting. A low test of elbows, depending on how many elbows you have in the system, if your glues aren't correct and if you don't support the system properly, there's weight there, and that could put a lot of stress on the elbows, pull it apart. Low temperature handling, condensate, again, can the material handle that acidic nature? UV rays, what does that do to our system? Can it possibly denigrate the plastic? All right. Pressures, okay, because there's volume when we make flue gas, and there's the condensate itself, the weight of that condensate, the pressure on the system, and then what happens if we get to elevated temperatures? What happens to the material? Joint sealing and tightness, it's really quite interesting. Impact. So a couple of things that are not addressed by the standard, the ASTM typical standards that we showed you earlier. Low test of elbows. It has to be able to handle 4 times the weight of the maximum distance between elbows. All right, the vent manufacturer or the appliance manufacturer will tell you how close elbows can be and how many you can have, and what the equivalent length is, yada yada. But it has to be able to handle 4 times the weight. So I want you to think about this. There's venting systems you've seen out there where they don't have good pitch, and if I've got condensate ponding or pooling within the venting, that adds weight to the system, and that'll put stress on your joints, your glue joints. Low temperature handling. At -4 degrees for 5 hours, they would drop the material onto concrete. So I want you to think about this. We use a lot of PVC, CPVC for venting, obviously. That's going to be sitting out in the pipe yard at your wholesaler. At 50 degrees, at 50-degree outdoor temperature, if I drop that pipe, and I'm not saying we're going to forcibly drop it, but just think about pulling it off of the pipe rack, putting it on your truck, maybe you're dropping the end on the ground before you hoist it up onto the truck. At 50 degrees, the potential of cracking of that pipe, and a crack that you won't see, is very high. And as it gets even colder, that becomes greater. So you can have a micro crack or more in the pipe, not even know it. And that only happens at 50 degrees. So to get this ASTM to get the UL listing of 1738, we have to pass that at -4 degrees. Condensate management, again, being able to handle the corrosive properties of the liquid. UV protection. UV breaks down plastic. You'll see it on your patio furniture after a couple of years. Get your biggest buddy, hand him a beer, stick him in that chair, and the chair explodes. If you start to see the plastic turning a little bit white, you know what's going to happen. All right, so that can actually damage your venting, the piping that's outside exposed, but that heat energy that is caused by UV can also damage inside. All right. Pressure handling, we have to be able to handle 2.5 times rated positive pressure. So, to get that UL 1738, the material has to handle 2.5 times the pressure rating, okay? An elevated temperature, that means it's tested at 70 degrees above its rated temperature. So our Centrotherm poly pipe is rated up to 230 degrees. Gentlemen, that means we've passed a 300-degree test. You cannot do that with CPVC. You cannot do that with PVC. Okay? Really 140, and you'll never see that from a PVC or CPVC pipe manufacturer giving you really a temperature rating. But the standard in the industry is about 140, and code gives it a 10-degree, grace of even 10-degree higher, so up to 150. We get past those temperatures, that pipe's going to start to denigrate. Not a problem with our poly pipe. We can handle 230, but really we're tested up to 300. So those are pretty big, hurdles to pass, and the Centrotherm product does pass that. The importance of UV rating. What happens? What can UV cause? All right. Well, studies have found, as you can see on the screen here, that UV can start to denigrate the pipe. And if there was any impact on the pipe, it could cause a problem. So impact, what are you talking about? Well, we do get some high winds, and I get branches that bounce all over my roof when that happens. I got a lot of trees near me. So something like that, if it was to hit a piece of venting material that was PVC pipe, that could damage the vents. All right, we don't want that to happen. And that UV can also impact interior of the venting, even inside the home. And you can see on your screen there, let me see if my remote will work. There you go. If you look right here, you can see the pipe starting to discolor. And that is the exhaust. So besides UV from outdoor, I got some higher temperature coming off of this system, and that's why that pipe is starting to discolor. All right, intake pipe, no issue, but here on the exhaust, UV and high temp starting to discolor the pipe, starting to break it down. So again, how UV can actually damage interior of it, right? They have found that heat from the sun, it'll travel down into the system, overheat the venting material, all right, and also help that to start the, process of it breaking down. We don't want that to happen, okay? Any questions so far on that? I just threw a lot at you when it comes to that type of material and how we have to pass that UL standard of 1738. Any questions, ladies? Nothing? No? We're good? We're killing them today. All right. So when it comes to your insulation requirements, you have to follow local code. You have to follow manufacturer specs in regard to where you penetrate the building, staying away from windows, doors, getting above peak of roof, all that kind of stuff. You have to be able to follow those specs. And you cannot mix manufacturers. You can't go from PVC to a poly pipe to stainless. Once you start, that is the system you're supposed to finish with. And believe it or not, I've got pictures of where they come off with PVC from the appliance going through the home, and in the middle of the wall, they try to glue or even duct tape poly to PVC, and we can't do that, all right? And it's a dangerous situation. We don't want that to happen at all, okay? All right, so moving forward. So now codes and standards have changed, and the NFPA 58, the National Fuel Gas Code, International Fuel Gas Code, all right, of all now stating UL 1738 is the standard. All right, so not to waste time, but National Fire Protection is calling out that in the category 2, 3, and 4 venting, if the manufacturer is not listing exactly what material, that you want to use material that follows UL 1738. Same for National Fuel Gas Code. If it's not called out specifically by the manufacturer, this is what you want to use, a UL 1738 product, all right? Same thing for International Fuel Gas Code here. If it's not called out, it's got to be a UL 1738. And even the PVC, CPVC manufacturers are calling out a UL 1738 product to be used for venting. So I don't know of any listed PVC or CPVC type of product out there. The polypropylene product is your best bet, and Centrotherm is the leader for that. Just to let you know where we stand across the country, you can see a couple of states here. This is their standard. They're not even allowing PVC. New York City, that is a fact. It's been for quite a long time. They're starting to use that throughout New York State. They're doing it in Massachusetts. And again, I've been in contact with the state, just asking them, when is that going to happen here? What's the timeline? And I've been told that they feel they're going to make that change within a year or two. So be aware of this, gentlemen. It's going to change how you're doing your systems and making sure that you use the proper product. So to sum all this up, UL 1738 will be your standard when it comes to category 2, 3, and 4 type of appliances. All right, that's where we stand. You want to make sure it can be a true venting system, not something that you're putting together and hoping that it's going to work. So more people are starting to switch to this product. And right now, with pricing out there and plastics going crazy and availability of material, because we have problems across the board with availability of all types of material now in our industry, the poly pipe is a very good bet because the pricing is very reasonable when it comes to PVC, CPVC. It is available. All right, it's an inventory. Obviously, Aaron and Company again is sponsoring this. It's an inventory there, so it's available for you. As you can see on the screen, it's engineered for venting. It's a safer option. We give you all the parts and pieces to build your venting system. You can see we have flex pipe on there. We've got hard pipe on there. I can use my flex pipe as through my chimney as a chase to bring in either combustion air or use it to bring out exhaust if it's going to be at nice low temperature. We get the UL 1738 rating, and we're available for these high temperatures. We're in good shape here. Okay, so our installation, there's no glues, there's no primers. All right, it is got built-in pitch, all right, which is very important. It's engineered for this, so built-in pitch is in there, meaning that my elbows are not a hard 90, there is pitch built in. So as I add elbows to my system, I'm sorry, Chris, I'm making you bounce back and forth with the camera. As I add elbows to my system, the pitch is built in. I don't have to worry about that. No glues and primers mean once I put it together, it's set up, it's ready to go. There's no setup time. I don't have to wait 24 hours for the fumes to dissipate, okay? Very important. And also, there's a gasket inside. Let me show you this. Hopefully you can see that on the camera. All right. All right. So if we look inside here, we can see a gasket. And this gasket's very important because anytime you put any type of hot media through a pipe, all right, and this means whether it's, you know, iron, copper, or plastic, the pipe is going to expand and contract. So this gasket allows for that expansion and contraction and makes up the difference, so we don't have an issue when that happens. And to make sure you understand what that means is if you look at a thermometer, whether the temperature is cold or hot, the mercury that's in there expands and contracts. So the same material, you know, will expand and contract, but since it's a liquid, you know, we have room in the thermometer for that to happen. The glass that it's encased in doesn't change. But in our world, since we're dealing with a rigid product, it's going to expand and contract. And if our material and our system and our glues or what have you can't handle it, it can break. So very interesting screen here shows you that even this big rock can split because of changes or fluctuations in temperature. High desert temperature during the day, that rock is absorbing heat energy from the sun. And then at night, the sun's, you know, gone, and now it's very cold there. It's going to give off that heat energy. So it's fluctuating, hot, cold, and at a certain point, that expansion and contraction can crack that rock. It can crack your vent material if it's not done properly. So what can that mean? That means we have the possibility, if we're not using proper glues and proper support of the product, we can have the product, if it's a PVC, CPVC type of system, have the joints pull out. All right, now I don't know if you've seen any of that on jobs, but I have. It's a little frightening. We want to make sure that doesn't happen. All right, so our sockets are deep, and because of the gasket, we have the ability to accept that expansion and contraction based on fluctuations of temperature. Any questions on that? Because that's a big deal too. No questions. All right. So, you know, if we're going to compare all the material, you know, to give it a real good, honest look, you know, when it comes to chemical resistance, polypropylene, PVC, CPVC, we can all handle the acidic nature of condensate, okay? When it comes to working temperature, we have a much greater range versus PVC and CPVC. Softening temperature, all right? We go up to 300, actually it says 302 degrees, where the CPVC and PVC much lower temperatures. You know, there is a push for environmentally friendly products out there. We are recyclable where the other products are not. and we don't leach any chlorine, and we're not sure about PVC or CPVC. All right. So again, can you use PVC, CPVC? Sure, as long as you're working within the parameters of what the material can handle. But if majority of installs are going in and not running in condensing mode, if the appliances are going in not running in condensing mode, your PVC, CPVC is the wrong material, gentlemen. Wrong material. And I want to state this, or really bring this to your attention. We go on a lot of jobs, and I'll see my product out there installed, and I see a wire hanging in the mechanical room, and that's because they disconnected the outdoor sensor. I asked the contractor, why did you do that? Oh, the homeowner, they tell me it doesn't feel the same. They're used to that blast of heat, because their cast iron boiler they've had for the past 20, 25 years, that's what it felt like. Well, it's up to us as an industry to educate how these systems operate. All these condensing boilers are going to work off of outdoor reset. They're weather responsive. So yeah, we'll feel different. Doesn't mean we can't heat the home. We are heating the home, but it's going to feel different. We do have to educate our customers all right, about this, so they understand. And different, companies that make these appliances have different features. All right, the one that we represent has a boost feature, so it has a boost that you can program in there, that if it's taking a while to get to room temperature, it'll up the temperature of the appliance to get there quicker. And the next go around or the next call for heat, that's where we start to operate. So, if your customer doesn't feel that initial comfort fast enough, the appliance can make up for it. But that means if the temperature gets higher, PVC, CPVC is not going to be, spinning as I say that, will not be the right material. You want to use a vent material that can handle that. All right. So I really want to make sure everybody understands that. So the next table that we're going to show you here on the screen also shows you weight per foot. All right. So the poly pipe, the polypropylene, the Centrotherm pipe is lighter than PVC and CPVC and stainless. All right. Now, it says here the maximum, based on OSHA standards, that a person has to lift with two hands is 51 pounds. All right. You guys are big, rugged guys out there. You can handle more than 51 pounds. But what that really is showing you, especially when you get onto union jobs, is that 2.5 lengths of PVC would be at that 51 pound mark. And a length and a half of CPVC would be at that 51 pound mark. Okay. Almost 8.5, 9 lengths of poly Centrotherm pipe get you to that 51 pounds. So, we can handle more of the material. It can move more of the material faster, help make the install faster on our jobs. Okay. So when it comes to assembling our pipe, you can buy the pipe in different lengths. We can cut it, we can measure it and cut it to whatever we need. All right. And then we chamfer the edge, no big deal. There is what do we want to call this? This is the Centrotherm glycerin or something. All right. We want to use that on our gasket, and you want to be, very liberal with it. Put plenty of it on there. Okay. And if you didn't have this, you could use water. Okay. So all this is being rubbed onto the gasket. Then we take our fitting, and we're going to use a lock ring, all right, to make sure it's going to stay on there. And we just slide this together, all right. So with the sealant, it's in there, and as we push it on, we're going to make our lock ring. It's going to snap on. You hear the click, and now we've made a perfect joint. Any expansion and contraction is taken up by the gasket, and the lock ring is to make sure that it's never going to pull apart. We have pitch built into it because, again, it's not a true hard 90, so that 1/4 inch pitch is built into the product, and off you go. No wait time, ready to go within a few minutes once you finish putting your system together. Now, based on length of run, we will tell you how often you have to put a support in there. So every 78 inches in vertical and every 39 inches in horizontal installations where you can use a support. Okay, and these supports meet the UL 1738 test requirement. Now, our Centrotherm catalog will show you these typical configurations when it comes to building up our systems. So the first one you're seeing up there is residential sidewall, where we're going to use a 2-pipe system because majority of the systems we see installed for either tankless product or condensing boilers are going to be 2-pipe. We're going to take outdoor air for combustion, and that's a single pipe, and then we're going to use another pipe to get our products of combustion out, flue gas. So you can see on the screen, we give you different options. We have the different caps that as you're going through the roof or even at the top of the chimney, if you're using that as a chase. Okay, so we have our different pipes. So you can use our pipe for your incoming air, or you could use PVC, but you want to use us as your exhaust piping. Next, you're going to see on our screen the flex. So we have the flex tubing, and I'll show you right here. Here's our flex tubing. So on the screen, what we're showing you is we can use a masonry chimney, again, as a chase, use our flex to run through that. Or if there is metal venting through that chimney, we can use the metal venting as a chase and use our flex product to go through the chimney, through the metal venting for our flue gases to come out. And we can use another pipe to bring in outdoor air, okay? Next on our screen, we'll show you some commercial where we can common vent multiple appliances together. We can do that with our Centrotherm. And again, use our products to go through a chimney as a chase, all right? So the catalog will show you all these different parts and pieces. You don't have to guess. It's very self-explanatory. So regardless of what I need, we'll show you the different configurations, the different products you're going to need, all right, to build up your system. We also have, concentric product, which would be a pipe within a pipe. So if you're going to bring your, want to make one penetration through the roof or one penetration through the sidewall, we can do that. We have our own concentric product. You can bring 2-pipe up at one point, all right, make your connections and have, a concentric product also. Now, the cool thing about Centrotherm, which is something I really like, and this helps out a lot, especially on commercial jobs, is they have a design and layout department. So if you give them a sketch of your appliances, give them the idea of how long venting is going to be, all right, how are you going through the building, they will give you what is called a vent bone, bill of materials. All right, so there's every single part and piece that you're going to need for your system. We can give that directly to Aaron and Company, and they can quote that on your next job. So a simple sketch becomes a comprehensive proposal in minutes, right? No worries when it comes to your venting, all right? So if we're going to summarize it, we want to make sure that we're using the proper venting material based on our system demands. If we're using condensing appliances, we want them to run in the condensing mode. If you're not sure how that happens, contact us, contact your salespeople at Aaron & Company. They'll help you design your system properly to make that happen. And you want to make sure you're using proper material. You want to use material that's listed, UL listed 1738, which the Centrotherm product is. That becomes now a complete venting system. It's a complete safety system. And gentlemen, you can sleep well at night knowing that you put in a complete system that will be functioning properly for the life of the appliance and give safety to that homeowner. Okay, so I've been talking a lot. Any questions here? None, honey? Nothing? Oh, I'm disappointed. Well, if you have no questions, that's great. If you do, you can always email me if you have at jdepalma@Wales-Darby.com, and we'd be happy to help you with your venting systems out there. So with that, I thank you for your time, and we'll see you next time. We'll see you Thursday, actually, for our next one. And if you want to review this again, you can go to HVACinsiders.com. Any of our webinars that we produce are recorded and they're posted on there, so you can watch this at any time. And you'll see all the other videos that we have done, or all the other webinars, I should say, when it comes to hydronics or wiring or any type of HVAC products that we've done. So HVACinsiders.com, or Wales-Darby.com, click on the training tab, and it'll bring you to HVAC Insiders. All right, so with that, I thank you very much. Everybody have a great day, and we'll see you next time.